Hello everyone! Ever looked at an infrared spectrum and seen those units, cm superscript 1, and wondered, why? Why not just use something simple like wavelength or frequency? Today, we're going to break down exactly why scientists prefer this special unit called wavenumber. First, a quick refresher. IR spectroscopy is all about making molecules vibrate. Think of the chemical bonds between atoms as tiny springs. When we shine infrared light on them, they can stretch and bend. But they only absorb light with the exact right amount of energy to make them wiggle in a specific way. So, how do we measure this energy? We could use wavelength. The typical IR range is about 2.5 to 25 micrometers. These are small, sometimes awkward numbers. More importantly, wavelength is inversely related to energy. A bigger wavelength means lower energy. That's a bit confusing to look at on a chart. You want the numbers to go up as the energy goes up. Okay, what about frequency? Frequency is directly related to energy, which is great. Higher frequency means higher energy. The problem? The numbers are gigantic. We're talking about trillions of cycles per second, or terahertz. A graph with axis labels in the trillions would be a nightmare to read and interpret. This is where wavenumber comes in to save the day. Wavenumber, written as cm superscript 1, is simply the reciprocal of the wavelength in centimeters. It asks, how many waves can you fit into 1 centimeter? And it solves both of our problems perfectly. Here's why it's so useful. Number 1, the numbers are convenient. The typical IR range becomes a nice, clean 4000 to 400 cm superscript 1. These are easy, whole numbers to remember and work with. That famous cardinal peak? Right around 1700 cm superscript 1. Easy. Number 2, and this is the most important reason, wavenumber is directly proportional to energy. Just like frequency, a higher wavenumber means a higher energy vibration. When you see a peak at a high number like 3300 cm superscript 1, you instantly know that's from a high energy, stiff bond, like an OH stretch. A peak down at 800 cm superscript 1 is a lower energy vibration, like a CH bend. This direct relationship makes interpreting the spectrum intuitive and fast. It directly connects what you see on the graph to the energy of the molecular bonds. So, in short, wavenumber gives us the best of both worlds, a direct, intuitive relationship with energy and a range of convenient, easy-to-read numbers. It's the Goldilocks unit for IR spectroscopy, not too big, not too small, and directly linked to what we really care about, energy. Thanks so much for watching. I hope this cleared things up for you. If you found this video helpful, please consider giving it a thumbs up and subscribing to the channel. Your support helps me create more content just like this. See you in the next one.